I hope you're all fine. In this lesson, what we will study, now we should start with the lesson objectives. What are they? We will study metals, metalloids, nonmetals group in the periodic table, and valence electrons, and what is period in the periodic table. Okay, one by one we will study these all. Let's get started. How are the elements arranged on the periodic table? A zigzag line on the periodic table divides the three major categories of elements. Okay, metals, nonmetals, and metalloids. Now, this is the zigzag line, okay? In your book also you're able to see this diagram. Metals are elements that are shiny and conduct heat and electricity well. Okay, the metals are seen as a blue colored boxes inside of this periodic table. Okay, all of the blue ones are metals. You see the zigzag line, the left side of the zigzag line, all are metal except hydrogen. Okay, hydrogen is gas, but the others are metals. You see here metals, you see two elements also over here you are able to see. Okay, these two are metalloids. Okay, the blue ones are metals. What are metals? They are shiny, conduct heat and electricity well. Now, elements are the left of the zigzag line are metals. Okay, except for hydrogen. Yeah, let's get started. Let's move forward. The elements to the right of the zigzag line are nonmetals. You see, nonmetals are the right side of the zigzag line. Okay, the purple colored ones are what? Nonmetals. Nonmetals are poor conductors of heat and electricity and are often dull and brittle. You're able to see over here, nonmetals are actually as a physical property also they are different from the metals. As a chemical property also they are different from the metals. You are able to see there the metals actually have different physical property, like they are shiny, they are hard mostly, right? But for example, here mercury, the mercury is not that much hard, we can say. It is even liquid in the room temperature, mostly in most temperature it is liquid, and that's why it is considered as an actually metalloids. Now, what are the metalloids? Metalloids are elements that have some properties of metals and non-metals. You see, they border the zigzag line. You see here the zigzag line over here. There are 6 elements around this zigzag line. Okay, they are all metalloids. Okay, metalloids, metals, and here non-metals. Okay, I think you understood. Okay. List 3 metals, non-metals, and metalloids. I don't want, you to solve this question. I have another idea, actually, in the biochemistry, in chemistry, even in physics, you will be able to, in biology, you will be able to see, often you will be able to see those elements. What do I want? I want you to memorize just chemical names, just element, name of the element and the symbol of the element, chemical symbol of the element. I want you to know. As I explained you before, you see at the top you are able to see atomic number. You do not necessary to memorize these all atomic numbers of all elements, right? Just I want you to memorize, chemical symbol and aluminum, the element name you have to know. Just you see I have circled the important ones because mostly you will see those elements in the questions throughout your education, even in the university. That's why you have to know, right? You have to know the chemical symbol of those elements and the name of those elements. If you do not know, definitely you will be embarrassed in front of your all classmates, right? You have to know the basic ones. Look, first of all, hydrogen, 1. Hydrogen, H, okay? Sodium, Na. Magnesium, Mg. Potassium, okay? K. Calcium, Ca. Maybe you know most of them, just but I want to be sure, right? Chromium, Cr, okay? Mn, manganese, and iron, right? And cobalt, Co. And osmium, why it is important? Actually, it is the most dense element in the nature, what we know actually. Why it is in the middle of the periodic table? That's why it has the highest density. Okay, look at here, nickel. You have to know Ni, Cu, copper, Sn, zinc, right? And silver, Ag. You have to know Au, gold. And mercury, Hg, aluminum, Al, boron, B, silicon, Si, okay, arsenic, As, sorry, and germanium, Ge, okay, here, iodine, so important, I, okay, krypton, you know, this is not element of the Superman's, okay, Superman's element. It is actually, krypton is used, it is radioactive and it can be used as a source of energy like uranium, right? Nowadays they are producing energy with one, not that much definitely radioactive it is, but we produce energy from the krypton as well, and it is used by the, you know, Elon Musk, nowadays to send the to fix the actually artificial satellites in the orbit. Okay, recently actually each and every month he sent 60 I think it was 60 what he sends, actually artificial satellites he sends to the space. Okay, and you have to know argon, neon, and helium. Okay, you see most of the elements, actually symbol of the elements start with the actually letters of the that elements. Argon, Ar, you see, neon, Ne, helium, He. That's why it is easy to know it, just if you know the name of those elements. Okay, fluorine, for example, oxygen, nitrogen, carbon, okay, silicon, phosphorus, sulfur, chlorine. Okay, these are all, and uranium over here you have to know. Okay, let's move. Each vertical column of elements on the periodic table is called group. Here, each and every vertical column of the elements in the periodic table are called group or family. Why they are called group? Because they have same chemical property. Okay, in the group 1, all of them have same chemical property. In the group 18, for example, all of them have same chemical property, and also most of physical property as well. Why? Actually, they make the same type of the reaction with other elements. Okay, I will explain furthermore. Now, elements in a group are similar because their atoms have the same number of valence electrons. Valence electron is the outermost layer of the electron cloud. Okay, as you know that in the Bohr model I explained you, for example, here hydrogen has just one layer of electron, right? That's why it has just one electron. How about the lithium? Lithium has 3 electrons, and lithium has 3 electrons, and in the first layer it has 2, in the second layer it has just 1. In the first layer every time there should be 2 electrons, in the second layer maximum there can be 8 electrons, in the third layer maximum there can be 18 electrons, right? According to this rule, actually we will put the number of the electrons on the electron cloud, and we will see how many electrons are present on the valence electron, as a valence electrons on the outermost layer of the electron cloud. Now actually I want to explain more this point. Over here you are able to see, if we look at here, sodium and potassium. I will actually explain it furthermore in the further slides more. Actually sodium has how many electrons? Sodium has, as I explained before, the first two electrons in the first line, in the first actually energy level of the electron cloud. In the second one it has 8 electrons like this, okay. In the third one it has just 1 electron, okay. How about the potassium? Potassium also has same. Actually it has also 1 electron on the second one, in the outermost layer, okay. In the first one it is 2, it has 2. In the second one it has 8, total 10, right. In the third one it has again 8. In the fourth one it has 1. You see, it is now 19. You see, it actually, when it reaches the 8, actually it is a little bit complicated, but it doesn't go directly to the 18. First it fills 8. After that the extra one added to the fourth energy level. After that, when it reach also 8, after the 8 again the other electrons are added to the third level. Okay, it is a little bit complicated, leave it. But you have to know that valence electrons here, simply why valence electron is that the outermost layer, the number of the electrons on the outermost layer of the electron cloud, okay. That's all actually. And you are able to see we will work with the elements which has less amount of electron. That's why it will be easier for you, right. In the grade 10 you will actually study more about these things. And after this lesson, we will start chemical bonding. Over there I will explain a little bit more, but it is easy, don't worry about that. Okay, I hope you understood what is the group. Group is here, group 5, group 6, it's written there as well. Okay, they have same chemical and physical property. Now you see here neon and xenon, they are both present in the group 18, right. In group 18, that's why they can make the same type of the reaction when electric current pass through them. You see how much they are similar, right. They glow brightly when electric current actually flow through them, pass through them. The second example is here. You are able to see here sodium and potassium. Where are they? Here, sodium and potassium, and they are both in the group number 1. You see, group 1. That's why they made the same reaction when they come together with the water molecule, okay. When they come together with the water, they actually make the same type of the reaction and they explode. Over here you are able to see sodium and potassium, how much they are similar. Why? Because they are in the same group, okay. The elements which are present in the same group, actually same type, they have same type of the chemical property. Now here valence electron participate in chemical bonding, okay. Actually the chemical bonding between the two elements depends on the valence electron. I told you that valence electron are the electrons which are present in the outermost layer of the electron cloud. Actually here it is not shown as an electron cloud, but in the Bohr model, as a Bohr model it is shown here. You see, in sodium we know that there are 11 electrons, 11 protons and electrons. What happens to sodium ion? Sodium, not sodium, actually element. Why? It is not ion yet. Why? Because in the as a valence electron, there is just one electron over here, and in the chlorine there are 7 electrons in the outermost layer. Total it has 19. It has 17 electrons. Okay, chlorine ion over here, chlorine 2 10 17. Okay, chlorine atom over here, it has actually 7 electron as a valence electron, right? 7 electrons. Actually, each and every element wants to complete its valence electron to the 8. Okay? You see here it has 7 electrons and it needs just 1 electron to complete it as 8, right? And the sodium element over here, it needs to give one electron out of the atom to complete its valence electrons to the 8. Okay? That's why what will happen, sodium ion will give its 1 electron to chlorine. Actually, it is not our topic, just I am explaining to explain valence electron. And they make the one bond, ionic bond over here, right? And sodium chlorine, they become salt, right? When it is dissolved inside of the water, and we are able to see sodium ions and chloride ion inside of the water. What was the ion? The charged atoms are called as an ion. Why it is plus? Because it lost 1 electron from the atom. That's why it is number of the protons inside of the sodium ions are more than numbers of the electrons. Number of the protons are more than number of the electrons. That's why it is positively charged ion. And here number of the electrons are more than number of the protons. That's why it is negatively charged ion. Okay, I hope you understood what is the valence electrons. Valence electrons are electrons which are present and on the outermost layer of the electron cloud. Okay, now each horizontal row of elements on the periodic table is called a period. Okay, periodic table, in the vertical line is group, horizontal line is period. Physical and chemical properties of elements change in predictable ways from one end of the period to the another. Okay? Atomic size decreases, for example, atomic size decreases as you move from left to right across the period. You are able to see here actually horizontal line is called as a period, right? Actually you can easily predict how chemical and physical property will be changed from left to right on the periodic table. That's why you know that we say period, actually periodic table. Why? Because each and every property periodically repeated in the periodic table. Elements in the middle of the period are most dense, for example. It is another issue. I told you osmium actually, it take its name from the Ottoman Empire because it is firstly discovered in that region in Anatolia in Turkey. That's why they have given this name, right? You see in the middle of the period, the elements has highest density. From right to left, left to right, okay, the density increases till in the middle of this a periodic table. As you move from left to right within a period, the atomic number of each element increases by 1. You see, atomic number is 19 over here, then 20, 21, 22. Do you see? Actually, you may easily predict that the number of the electrons, number of the protons are increased in the elements when you move from left to right. That's why it is called periodic table actually. The lanthanides and actinides are placed below the table to allow the table to be narrowed. Okay? Okay? Why it is necessary? To allow the table to be narrowed, it is actually fixed over here. Okay? between the third and fourth group. But you should know that, for example, thorium belongs to group number 5, but it is not very important. Okay, just you may say that to narrow the periodic table, lanthanides and actinides are placed below the table. Okay, that's all. Okay guys, I hope you understood all. Please don't hesitate to ask any question. Have a nice day. Take care.